Here's the IBM Memory 100 typewriter, and I found out a lot more about how the mechanism on this works through looking at bitsavers.org, and I found a lot of literature on the IBM Selectrics, and that helped me fix this one here. This one's working pretty good now, as you may have seen in another video. This one's still having some problems, and the thing is that the mistakes it's making are intermittent. And looking here, I repeated the quick brown fox jumped over the lazy dog 1, 2, 3, 4, 5, 6, 7, 8, 9, 0 times. The problem is that the errors are intermittent. Like some places it's saying, like if we just look at dog, someplace XOG, XOM. And let me try it manually here. I've got it working pretty good manually, better than it was. See, that's pretty good. But the playback from the computer is still not right, and what's really aggravating is that the errors are non-consistent, like I was showing before. In some place jumped will be jummed, and someplace it'll be 1/2 or something. So to try to figure this out, I studied those manuals, and I found out about how the tilt and rotate mechanism works. And the codes are, there's 6 solenoids on this, and this mechanism is exactly the same as on the mechanical ones. You've got these linkages for tilt, and this, when this pulls down, you get 2 units of tilt. This one, you get 1, both of them for 3. On the rotate, this one, when this one gets pulled down, you get 1 unit of rotation, 2 here. Both of these are 3. This one's called the Rotate 2A, and it's used only in combination. It's used in combination with the Rotate 2 to get 4 units, and with the 1 and 2 to get 5. This lever here gives -5, and then you get -4 through -1 by adding the -5 pull down along with the appropriate amount of positive movement on this side of it. And so that's what the solenoid's doing. And what happens is when a solenoid pulls out, and those little wires down there, when a solenoid pulls out, that means that feature is inhibited. So for instance, if you need 0 tilt, or 0 rotate rather, you pull out all the solenoids, each one has power, or 1, and because they're all pulled out, all 3 of these levers work. And now let me see, is that wrong? No, I'm sorry, that's I knew I would make a mistake with this, because it's just kind of complex to understand. When these are pulled out, it inhibits motion. So when they're all pulled out, there's no motion. But you don't want -5, so it has to be pulled out. So that means all the solenoids are pulled out, or they're all activated. But if you wanted, for instance, +5, you still want to pull the -1 out so that you don't get -5 rotation. But you don't want to pull any of these ones. You don't want to pull any of the wires out on these ones, so these levers are all pulled down. So I figured out this chart of what movement, what patterns of solenoid actuation give what movement. This chart here is just for rotate, but tilt is similar. And then I got the type ball and I figured out the rotation chart, because I knew that from reading the literature, Z is 0 tilt and 0 rotate. And then I just looked at the type ball, Positive rotation counterclockwise, negative is clockwise. Because negative rotation means that this, let's see if I can manually actuate it here. Let's see here. If this pulls out, that's called positive rotation. See, it's going counterclockwise. And if that gets pushed back in, that's called negative rotation. So positive is this way. And so I figured out all those characters for what's positive and what's negative, and I tried to adjust the solenoids starting with a group where only one solenoid was activated, that is +5. And for +5 you want to pull down all of the positive whiffletree linkages. That means you have no solenoid inhibition of those linkages. You only want to inhibit -5. And so I adjusted those so that I would get a pretty good result from this group of characters. And this represents the tilt. You have 0 tilt, +1, +2, or +3. And I got it adjusted pretty good so that on a manual typing it works like it should. But doing it automatically, there's so much intermittency, I'm not sure where the problem is. And I have gotten some occasional intermittency in wrong character selection on manual typing. Because what I did, let me show you where the solenoids are here. I loosen the nut just holds it in place. I loosen the nut all the way, turn the screw down in all the way so that you'd have the least tension on the wires from the solenoids. And then I turned it back out till I got the correct character, and then turned it just a little bit more. And so I've mostly been able to improve the manual printing, but I just don't know from the automatic where the problem might be. The next step on this is going to be to build an LED-based analyzer to connect to the solenoids. I'm going to need to use a data latch circuit to enable storage of the codes on LEDs, because the solenoids are only pulsed intermittently when a key is pressed. I need to build a data latch circuit that will store the pulse code on the LEDs and then build a way to clear it. And I have to hook that up to the solenoids so that I can see what's being fed out of the computer circuits and see if what electrically is going to the solenoids is matching up with what needs to be happening mechanically with the mechanism. So I'm going to put this aside for a while. I've really been puzzling over this darn thing for pretty intensely, and I figured out all of this logic for it. So next step will be to build the LED analyzer, but I won't do that for a while. I'm going to go ahead and work on something new here. But it has been a big help and given me some mental peace of mind to know more about how this thing actually works. But I think what I'll really need is some specialized service literature on this, because this adds like a twice again layer of complexity. Not only is it a mechanically very complex machine, it's got computer circuitry and solenoids and all this electronic stuff on it. So I'll try and be nice to get some more literature on this, and I'd like to thank the member who said he'd contribute some literature, so that would be greatly appreciated, anything you might be able to find on it. So I'm gonna just put this to the side for now, but hopefully we'll get it fixed, maybe with the help of that analyzer to analyze the actual data going into the solenoids.